We have a very exciting New Year update. India plans to usher in its 2024 by launching its first ever X-ray space observatory to observe the biggest, brightest phenomena in the universe through X-rays. The spacecraft, which will be about 469 kilos, will carry two instruments which will study X-rays from the same source for information about the X-ray characteristics and their behavior so that the nature of the source that they come from can be understood. The mission is academically led by the Raman Research Institute in Bengaluru, and it is being developed in collaboration with ISRO's U.R. Rao Satellite Center, which is also in Bengaluru. While the U.R. Rao Center has developed the XPECT payload or instrument, Raman Research Institute has built the POLIX payload, and these are the only two payloads that will go up on this space observatory. This mission will launch on New Year's Day as of now on January the 1st from Sriharikota, but the launch window or the launch timings is yet to be announced because it depends on the weather at the time. The mission that it will launch on will be the PSLV C-58 mission, and this spacecraft and space observatory is expected to operate for at least 5 years in orbit. So, to understand what this mission will do, let's first understand why we need to study X-rays. This mission will study the polarization of X-rays. So, what is polarization? A wave of light is said to be polarized when the orientation of the oscillations of the electric field in this transverse sinusoidal light wave is at an angle to the magnetic field. Understanding the various angles and intensity of polarization will provide further clues into the nature of the source that creates these X-rays and the mechanism behind how they're created. The objects that XPoSat will observe would be some of the brightest and highest energetic objects in the universe. The observatory will fix its X-ray gaze towards high energy, intensely bright, extremely powerful sources. These include things like, of course, black holes, but also pulsars, neutron stars, and supernovae. But if they're so intensely bright and energetic, how would this observatory study them? Well, these objects would be observed when the observatory is on the other side of the Earth from source. So the observatory, XPoSat, and the source have the Earth in between them. So the X-rays that are coming from the source will emanate from the sides of the Earth that this observatory can then observe and study without directly looking at the source. And to do this, XPoSat will be placed in a circular orbit, a low Earth orbit, at about 50 to 700 kilometers. Scientific objectives of the mission, as listed on the ISRO website, include studying the structure and geometry of magnetic fields of neutron stars, mechanism of X-ray emissions in pulsars, which are rapidly spinning neutron stars, studying X-ray emissions from the poles and the polar caps of neutron stars, and even understanding if supernova remnants emit energy more as thermal radiation or as non-thermal or non-heat energy. So what are the payloads that are going to go on this spacecraft that will help us understand these objects? First of all, understanding the nature of polarization of X-rays from an object help us understand the characteristics of the strength of magnetic field around this object. In turn, this then provides the nature of the objects and mechanisms behind how these sources emit radiation. The two payloads that will work in the medium X-ray range and complement the X-ray data brought in by NASA will be POLIX and XPECT. The polarimeter instrument in X-rays, or the POLIX payload, is the primary payload, and it is, of course, as the name indicates, a polarimeter. It will measure the degree of angle of polarization of incoming X-rays. This instrument is entirely developed by Raman Research Institute. The X-ray spectroscopy and timing, or the XPECT payload, is a spectrometer that will study the timing of X-ray emissions and how frequently they occur from the source. This instrument was built by the Space Astronomy Group at the U.R. Rao Space Center in ISRO. The entire scientific community, the astronomy and astrophysics community especially, is extremely interested and excited about this launch, and the findings will bring in new kinds of data that we haven't seen in this medium X-ray band before. XPoSat will be India's third space observatory after AstroSat, which was launched in 2015, and Aditya L1, which is currently on its way to L1 and was launched in 2023.